Hi my friends, once upon a time in the year 2016 I found this book on the net. 507 mechanical movements. A lot of mechanisms with animation, some of them, and I went to index at the letter I, intermittent movements, and I selected this one, 398. You see, this is an animation with a cam, a follower, and a wheel. The original drawing was this one, and if you are curious, you will see that this is a book from 1868, my friends. And the book was completed by Matt Kevaney with that animations. I selected a moment of this movement and I made a capture. This is the capture. I was interested to scale the cam and place dimensions, so I made this picture where you can see everything. The main points are numbered from 0, 1, 2, 3 to 5. They cover all the circle. The first moment is 0 degrees, then 70 degrees, where the lift, the movement of the follower, is 47. And the name of this movement is lift, with the symbol H max. You see a basic circle, which is the base for measuring the lifts. And here there are listed all the data, all the necessary data to create the cam. Points, angles, and lifts. Using this I made a cam and the assembly, and I made a movie. As you can see, the film follows exactly the animation in the book. This film was produced with the Inventor Studio module, which is part of Autodesk Inventor Professional. Let's study the model for the moment. As you can see, we have some parts. Let me make this transparent. You see the ball bearing here. The follower, the crank, and the wheel. Now let's rebuild the mechanism in Inventor. New, standard millimeters IM. Instead of place, now you know the procedure from my previous tutorial, I bring parts with drag and drop from the Windows file browser, as you know. We start with basic plate, which comes already grounded. We change the lights to be like in the original film. No big deal. 2 lights and settings with the 6, not minus, plus 6 around on 31, and the light 2 to be white and to have 75 brightness, and orientation to be 20, and 41. This makes a good illumination of the ambience. General brightness 55, ambience 15. Save and close. It looks better now. Yes? Good. Now we have to create the cam, but firstly I want to change the roller bearing, which is this DIN 625 SKF, because it seems to be very inappropriate. It's too great. So I go to open from Content Center, and I have this already selected. Let me see what are the dimensions. Table view, external diameter is 16 and I want to be 13, so I select this roller bearing. Remember, the inside diameter is 5, the width is 4, 13, 5, 4. Okay, now we know the dimensions to be used. Good. This assembly was saved, so we can activate this cam tool, but we have to keep pressed the key Control on the keyboard and then click here to obtain the default dimensions. We change the basic radius because we have this data. Basic circle is 38, so the radius is 38 divided by 2. The roller bearing has its dimensions, so we place them on the table. Basic dimensions, as I said, 38 divided by 2. Roller radius 13 divided by 2. Roller width is 5, as you know, and we have to establish where to be placed the cam. I captured for you the old table. This is what we want to have. The blue line is the position of the follower or roller. The red one is acceleration, and the yellow is the speed. The yellow is very low visible, and we can consider this image to know to have this curve. They are this one: position, speed, acceleration. Yes, they are blue so that they are present here. The other are not. Another important thing is about the segments. This is the segment 1, which has some data. You find the segment from here, or by clicking the segment on the graphic space. Good. Let's apply our new data by taking them from here. As you can see, the first point is 0 with lift 0. What is the lift? The lift is the movement of the roller, and it has the symbol H max. The first segment is this one of 70 degrees. Number 1, 70 degrees with the lift of 47. This is good. Let's apply this. It is not a big deal, but you have to be careful with one important thing. Which one? To click on calculate. After you place dimensions or data, you have to press calculate. Look here. Now is applied the set of data which we placed here in the table. Now we want to change the data for the second segment. I can select from here. You see there are 3 segments now, or simply click here, and then we go to our data and we see 123 with 9. 123 with 9 is the second segment. Let's go to it. 1, 2, 3 and 9. Press calculate, my friends. Don't forget. Good. The next one is 185 with 31. This one. How can we create this new segment? Because we don't apply now. If I select this, we cannot place the lift at end. You see, this is not enabled. So now we create a new segment by using this button. This one will be always present, yes, with the end at the start. This is the start, this is the end, and this segment must be always present. Therefore we use add after. Now we select this new segment and we place our dimension 185 with 31. Calculate. Now you know. Click on the last segment, add after, select back the new segment, go back to the list, and we have to use 240 with 17, 240 and 17 the lift, or H max. Calculate. Click here, add after, go back, and the last is 290.47. 290.47. Calculate. That's all, my friend. Now we have all the segments in place, but I lost the geometrical reference for the cam, so I have to select them again. Cylindrical face here, face here. Okay. We have to save the part with the name disk cam. Okay, and we have the cam in place. Now I bring the cam, the old one, in this assembly to see what are its dimensions. As you know, this is 12 millimeters, the width. Measure. The diameter is 175 millimeters. The dimension is 12, like our cam. The distance here is 7 millimeters, but now you see this is the roller bearing is 5, so we can keep this 7. Good. The distance between the two faces of the channel is 13, because we selected a roller bearing of 13. I eliminate this and I edit our new cam, but I want to save everything here. The name of the object will be the disk cam 2. Okay. Double click. I start from the bottom with a sketch. The sketch has this position XY, and I draw a circle, F7. I draw a circle of 175. 175. And I make an offset of 13. 13. Good. This is to be extruded on 12 minus this, 12 minus 7. No, 12. Not this direction, the other direction. Okay. Then I select again this face as a sketch. Let me place it as I want. Make this everything as construction. Finish sketch and extrude the other direction on 12-7. Okay. What happened? Oh, I was wrong. Extrude the other direction, but not cut, join. Okay, because I want to have here a button. Good. A chamfer of 1 millimeter is at the edges of the cam. Okay. The material is steel carbon. The faces are gunmetal antique, and some of them, which I select now, this I keep shift pressed, again shift pressed. These are titanium polished, Okay, return F6, and we have the cam. Now save. Okay, we can rotate the cam, of course, but the hole is missing. Let me see what hole is here. Measure 12 millimeters. We have to apply a hole of 2 millimeters in the center of this cam. I double click on it. I click here, I select sketch. I go back because now I have a point here. Hole, this point, diameter of 12, and through the cam, not to the assembly, of course. Okay, return F6. Now we place the other components very rapidly. The lever, the wheel, the follower, and some other small parts. Let me place these ones in position. We start with the follower, which has this face to be placed on the guide here, and also this lateral face with this face. Apply. Then we select with this constraint insert, we select this circle to be placed over this internal. Apply. then the wheel over this circle, apply, and axis on axis. This axis over this. Okay. Now we have movements here, very nice. Even if we didn't place any shaft there. Let me place now the roller bearing, which must be somewhere here. I make transparent these two in order to have access here. I place from content center the part which is not this one. Change size. We go to 6 to 4, as you remember. 6 to 4, which has 13 external diameter. You see it here. 13, width of 5, and internal 4 millimeters. Okay. Where do we place this? Anywhere. We constrain with insert this face and circle with this one. Okay. We go back with transparency and we make tangent the cylindrical part of the bearing, tangent this with anyone internal. Okay, and now we have perfect movement without shafts. You are advised to use my web page and download from there all the shafts and finish the mechanism. That's all for today. Thanks for watching. Bye bye.